All right, so I want you to go in your book, in the book, and it's the notes day 4, and it says trinomial factoring and tricks. So go to notes day 4. If you can find that page number before me, throw it out there. 93.
Yep.
Yes. Okay, so I'm pretty confident most of you can factor at some level. But I think some of you get your rules confused and you kind of memorized your way through it a little bit back when you were in algebra 1 and pre-algebra, and you're still a little shaky. And I'm guessing that because I've already seen some of you make some really horrible factoring mistakes. And sometimes they're careless, but sometimes I'm looking at them going, oh my goodness. Okay, so it's okay. We're going to start from scratch. Pretend you don't know anything. You've got a trinomial. Now, not every trinomial is a quadratic. What makes this as a quadratic is you go x squared, x, and no x. And sometimes you'll see them where they'll go x squared, x, no x, but coming from left to right, you'll have no y, and then maybe a y, and then a y squared. Okay? So we all talk about, even though that technically is not a quadratic in the sense that it's not just x's, it does have a quadratic feel to it. So if you see, and also you could have even something like x to the 4th, x squared, no x. Is that kind of making sense? Or maybe even x to the 6th, x cubed, where your powers are decreasing in half until they go away, like maybe powers of 2, I guess you could say. But anything like this that's in what we call quadratic form, if you have a trinomial like that, these tricks will work. Okay, now, what I grew up doing, I didn't learn magic number stuff, turning stuff into 4-term polynomials. I never learned that. In the old school math, we just guessed, checked, and revised. Okay, and what I mean by guess, check, and revise is, I know that if this does factor, it's going to factor into 2 binomials, right? And I think we all know that. Assuming there's not a GCF that comes out first. We talked about GCFs, and you can look at these 3 terms. Is there a term that you could factor out of this? Okay, now that is the number one thing you want to do. Pull out that GCF first. But in the absence of that, right here, I am going to assume it's going to break up into 2 factors. Now, if I had, pretend for a second that you actually had the factorization right in front of you. If I foiled it back together, what would the first times the first have to give me?
10x squared.
10x squared. So if I know that, then I only have certain options for this. What are they?
2 and a 5, 10 and a 1.
Okay, so I could have a 2 and a 5, right? And I could have a
10 and a 2, 3, 4, 5. Wait, do it right on this one, next one.
Hold on, 3, 4, 5, 6. I'm going to go down here and put 10 and a 1. All right, so I can have a 2 and a 5, and I'm going to leave 6 spaces for that. Not that you would know that necessarily right in a second. Or it could be a 10 and a 1. Now, that's the first times the first. So I know that could happen there. However, if you had the factors and you had foiled it, what's going to give me the negative 6?
6 and a 1, or 3 and 2.
Now, really, there are a lot even more options than that, right? Because not only could I have, say, 1 and 6, but I could also, like that technically that's a negative 1 and a positive 6, which would give me negative 6, right? Not only could I have that, but I could also have the negative 1 and the 6 in a different order. Either one of those is still, so I'm going to keep the 2 and the 5 out front. So I could have the 2 and the 5 out front and negative 1 and 6, or the 2 and the 5 out front and 6 and negative 1. What else could I have thinking about that? Okay, so instead of having negative 1 and positive 6, I could have had negative 6 and positive 1. Are you with me? And that negative 6 and positive 1 could have been in the order with the 2 and the 5. It could also have been positive 1 and negative 6. Actually, you know what? I think I'm going to need more spaces than this.
Because wouldn't you have to go through and do the same thing with the 2?
Okay, so now I'm going to have to go and, we're going to use what we need to use here, okay? Right? So now I got to do what? Not only 1 and 6 works, but also 2 and 3. Now, I haven't checked any of these to see if when you do the outside and the inside, you get the correct middle term. But my point is, there are a lot of options, aren't there? I'm just getting started. I could have the 2 and the 5 with a 3 and a 2. I could, with a -3 and a +2. I could have the 2 and the 5 with a +2 and a -3. Actually, that's not a possibility. You know why? You might not notice this right off the bat, but if this was a possibility, wouldn't a 2 factor out of that? And if I factor a 2 out of that, I should be able to factor a 2 out of the original, and I can't. But I'm just writing them all down for the heck of it, okay?
Wouldn't that be the same thing for the second and third?
Same thing for that. So all kinds of these that have 2s and that have an actual term that you can factor out of. Because if you can't factor it out of this, you're not going to have it factored out there. But we're just writing them out for now, okay? So I could have the 2 and the 5 with the 3, 2, the 2 and the 5 with the 2, 3. I could also have what? I could have the 2 and the 5 with, instead of -3, +2, it could be -2, +3, +3, -2. And you can look at that. That is 8 different options, right, for just dealing with the 2 and the 5. Now I would have to go through and do what?
Deal with the 10 and the 1.
All these different options with a 10 and a 1. So you'd have to do all of this with the 1 and a 6, and each time you did it, now again, you don't have to write them all out. You can write them out until you find the one that matches. And how do you find the one that matches? You've just picked what gives me the first and the last. You've done the F and the L of FOIL. Every single one of these will give me the correct F and the L when you FOIL it out. But only one of them is going to give me the correct, what I call the OI. The outside, inside. So let's just start. I haven't even started writing the ones with 10s and 1s. So I'm just going to do that and say ... But as I'm doing these, check it out. If you check the outer and the inner, this would give you a +12 and a -5. What's a +12 and a -5? +7. That's a -11. That doesn't work. If you check this one, -2, +30. That's not a -11. Throw it out. If you check this one, +2, -30. No. If you check this one, -12, +5. No. What about this one? +4, -15. There's your -11. +4x, -15x is -11x. That matches this. Now, hypothetically, you could be going through, you don't have to write all the options out on a guess, check, revise. You just have to start doing them and checking them as you go. But the problem, as you can see here, we've only written out half the possibilities, right? What if the one you write at the very end is the one that worked? Well, then you've just written out 1, 2, 3, 4, 5, 6, 7, 8, 16 different factors, and you're guessing them and checking them, and you're here for a long time. Now, this is not an exceptional method when you have a composite number out front. This guess, check, and revise is a great method when you have like just a single x squared. So if I ever have a single x squared, the options decrease by a large amount, okay? And then the guess, check, and revise method works really well. But when I start getting numbers out front like 10 or 8 or 12, and the way I can rearrange those first terms of each factor starts to become variable. Like there's a lot of different options, whether it's 2 and 5 or 10 and 1 or whatever. I would suggest maybe if you're struggling with this guess, check, and revise method to try this. And there's lots of names for this. Some people call it the magic number method. It's not really magic, but what I'm going to do here is I'm going to basically take this trinomial, and this is actually one of the things I talk about in the video. So when you get to this part in the video, you're going to go, oh, I already know how to do that. But I'm going to take this trinomial, and through this quick little process, I'm going to turn it into a 4-term polynomial. And I'm going to show you how to factor a 4-term polynomial. Now, the upside of this is, it's kind of robotic. Like you don't have any guessing and checking, and it will lead you straight to where you need to go. And if you're able to do the process, you'll know it early. And if you're able to break it up into 4, you know it's going to factor, and then you'll be able to factor. So I'm going to use this process a lot when that number is a little bit more complex, like a 10, because it's a lot of different ways I could break that up initially. So check it out. To do this little magic number method, and then I'm just going to do a lot of practice, and I think you'll see this not so bad. Okay? So to do this, I'm going to take this number. So I guess here would be your process. You're looking at this problem, and you're like, oh, crap, my lead number is 10 or 12 or 24. There's so many different ways to break that up. The guess, check, and revise. How do I even know where to start? You know what? I'm going to try this little 4-term polynomial magic number thing. So I'm going to take these two numbers, and I'm going to multiply them together. And I get negative 60x squared. And then what I'm going to do is I'm going to write down every possible combination of numbers that would multiply together to give me negative 60. Now, I don't have to write them down. I can just start writing them down, and when I see what works, great. So what are the options? I could have a negative 60 and a 1, or a 60 and a negative 1. And obviously, if it's an x squared, they would each have an x on it. Although most people I know don't bother writing the x as they're thinking. They just make sure they put the x in there when they get what they want. So both of those right here, but here's the trick. When you write the options down, the factors of this, they have to combine together to give you the middle term. Does that combine together to give me the middle term? Then I'm not going to be dealing with the 60s. So then I go to the 30 and 2 and multiply together to give me that. So negative 30 and positive 2, positive 30 and negative 2. Do those add together to give me negative 11? Nope. Then I go to, say, if 2 goes in there with 30, then 3 would go in there with 20. So negative 20, positive 3, positive 20, negative 3. Do those combine together and give me negative 11? No, they give me negative 17 or positive 17. And then I get to 4 goes in that 15 times. Negative 15, positive 4. Do those combine to give me negative 11? If it's a negative 15 and a positive 4. And by the way, if this had multiplied together to give me a positive, then what two numbers give me positives? Both positive or both negative. So those would be your options as opposed to switching the signs. Okay? Now, the second I find what works, you don't have to do the rest of this. But the second I find it, here's what I'm going to do. I'm going to replace negative 11x in my problem with that. So check it out down here. So there's my negative 11x initially. Okay? My negative 11x was right here under my hand. And I'm going to just not put it in there and replace it with the negative 15x plus 4x. Okay? So now I have a 4-term polynomial. It's unsimplified. Don't add it back together. You're right back where you started. So here's what I'm going to do. I am going to take the first two numbers and I'm going to group them together. And then I'm going to take the last two numbers and I'm going to group them. So I'm basically going to group them and I'm going to include that sign. If there was a negative on that 4x, I'm going to include it and then insert my own positive in there. So if that had been a negative, a minus 4x, I'm going to leave the negative with the 4 and put my own plus in there because I don't want to turn it into a multiplication problem, right? It's still addition. You're still adding and subtracting these 4 things. Now, is there a number, when you look at this and look at this, that you could factor out of each of these parentheses?
So the 5x in the first one.
So I'm going to factor out 5x in the first one.
And then 2.
And a 2 in the second one. And guys, this will work every time. What are you going to see?
The 2x.
They each have a matching factor. Now the worst thing that could happen is, instead of having a 2x minus 3, you might have something like 2x minus 3, negative 2x plus 3. But all you have to do to fix that is what? Factor out an extra negative so that the signs will match. All right, and we'll go through a number of these. You should see this stuff. Now, once I get to here, now you have this term and this term. Do they share a common factor? Yeah, they share that. So I'm going to factor out the 2x minus 3, I'm pulling it out, and when I pull it out, what's left? 5x plus 2. And that is a quick way to get to what I got over here. I always say quick. As you do this and get better with it, you'll see it's not as bad as you think, this process. But don't stop short. I see people every year, they group it like this, and they don't put a plus sign, they go, oh, it's factored. No, this is a process, right? You're changing it into two binomials, factoring each binomial, and don't stop here either. And at this point, in each binomial, you have a common term that I'm now pulling out. And don't pull out, you're pulling out one of each, but don't write squared when you pull it out. You're pulling one of each, drop it out, whatever's left goes there. All right, so let's just try a couple of these, and you tell me whether you want to use guess, check, revise, where you want to use this little magic number. I tell you what, in the first 4, let's just use guess, check, revise. So before you even get started, is there anything you could do on number 4? And by the way, the directions would be factor on all of these. I should have written that. So we're factoring these right here. Not simplifying, right? Because simplify would mean PEMDAS, and I would be finished. There's nothing I could do. But factor, is there anything you can do first? All right, so I'm going to take out the GCF. If you do that, it'll always make your life a little bit better. Now, don't lose the 2. You can't divide it out, because to do that, you would have to have an equation where you could do it to both sides. So I'm factoring it out, which is kind of like division, but I'm leaving it out there. And then trinomials, if they're going to factor, would break up into 2 binomials. Now, here's where I love doing the guess, check, revise. When I have a nice leading, whatever number leading the x squared is a 1, which is now a 1. Because now I only have one option for this x squared, which is x and x, right? So my number of possibilities just dropped in half of what it was before when you had like 10 and 1 or 2 and 5. Now, what are my options for 18? They are 1 and 18, 2 and 9, 3 and 6. And the signs could, if this is a positive 18, what do my signs have to be here? Based on the positive 18.
Yeah, it has to be both positive or both negative.
Both positive or both negative. But when you look ahead to that, that's telling you that when you FOIL it out, you'd have to add those 2 positives or add the 2 negatives. Well, you got to end up with a plus, so I'm guessing they're both positive. So if you want to just play the dumb game, check it out. Maybe it's 1 and 18. How do I check? Well, check out. You already picked the correct F, right? And you've already picked the correct L. So you're checking the OI and FOIL, right? And the OI would be the outer times outer plus inner times inner. And 18x and 1x gives me 19x. So that's not the option. And you go to the next thing. And again, I know you probably see that it's 3 and 6, but I'm just playing dumb here. If that was 2 and 9, right? And you actually, you picked the correct first and last. Let's check the OI. 9x, 2x is 11x. That didn't work. So then you go to 3 and 6, and you picked again the correct F and the correct L in FOIL. You're checking the outer inner. 6x, 3x is 9x. You're good. And remember, you factored that 2 out, and it is still sitting out there. All right? What about this thing? Is there anything you can take out? Any GCF? No? Okay, it is a trinomial. Is it a quadratic kind of trinomial? The powers are going 2, 1, nothing, or nothing, 1, 2. So that has a nice rhythm to it, right? So if it is going to factor, it's going to factor into 2 binomials. So let's just guess. What's the x squared going to break up into? X and x. Now what's the 12, that positive 12y squared going to break up into? What are your options? 6 and 2, 4 and 3, 12 and 1, but they both would have a what with them? A y. And if it's plus, the signs have to match, right? But if you FOIL them up, the OI is going to have to be negative. So what does that tell you? They have to both be negative because they have to match. So you can go ahead and put that in there. And again, you know they're going to have a y with each one because you're splitting that up. So the question is it 1 and 12, or 2 and 6, or 3 and 4? Well, with a little guessing and checking, again, at some point I'm going to get this, and remember, you've picked the F and the L correctly, but you have to check the OI. So outer, negative 6xy, inner, negative 2xy, combine them together, negative 8xy. Great. You with me? What about number 6? Any GCF come out? Okay, now most people do really well on 4 and 5 because there's a 1x squared by the time they get to factoring it, right? Right here, 1x squared, once the 2 is out, 1x squared. So they get sloppy, and this is what they start doing. They start going, oh, I just need to take factors of the 12 that combine to give me this. But as soon as the number has a 5 there, that doesn't work. You have to check the OI. The whole thing about factors of 12 that add to negative 8, that little mentality only works when there's a 1x squared. So if there's a 5 there, stick with your guess, check, and revise, or come down and do it this way later. So right here, what are my options since there's no GCF?
5x.
5x and 1x is my only option. Now I'm going to have a lot of options here because the last can be formed by going 1, 6, 6, 1, or 2, 3, 3, 2. Are you with me?
Yeah.
So let's just start guessing. If it was 1, 6, that's positive, so they have to be the same. But when I FOIL it out, it ends up negative, so they would have to be negative. Does this work? Now again, you picked the correct F. You picked the correct L. You have to check the OI. And you can't just go, oh, factors of 6 that add to give me negative 17. It doesn't work when that was, you have to say, check the OI. Negative 30, negative 1. Is negative 31 your middle term? Then that didn't work. Try something else. How about 6, 1 instead of 1, 6? Check the OI. Negative 5, negative 6. It's negative 11. Did that work for you? No. Get rid of that. Try 2, 3. Negative 15, negative 2. Does that give you negative 17? Then you're good. And even though this guess, check, revise method is not always your best method here in Algebra 2, because we beat you down with weird factoring and tough factoring problems, after this year, we don't do it anymore. It's just basic factoring. This would be considered a fairly rigorous factoring problem in Algebra 2, and they don't even do this kind of stuff in calculus. I mean, they almost always lead you with either an x squared term or a GCF that you could take out. So we're going to overplay our hand way more than we need to, but it does show up at math tournaments pretty nasty. So what about number 9? Last guess, check, and revise one.
Well, I would question it. Is it going to be like on a test, say like guess, check, and revise?
No, you do whatever you want on a test. Definitely can take out a 3. Anything else? An X. So make sure you take everything you can possibly take out. That's going to leave you what?
X squared.
X squared.
Negative 4xy.
Negative 4xy.
And 3y squared.
And 3y squared. Good. Now, there's a trinomial. If it's going to factor, it's going to factor into a couple of binomials. Let's see what happens. And like before, this is a good chance to use these because you now have a 1x squared. So breaking up the x, I have picked the correct first times first. It would have given me that. But breaking up the y, here's the nice thing about this one. How many options do you have for breaking up 3y squared?
You know it's only -1 and -2.
It's got to be 1y and 3y, right? So I can put the y there and the 3y there. And if it's plus, you have to have the same signs. But if it's a minus right there, you know they're both going to be negative, right? And so I really don't even have any options, but I'm still going to check, because if it's wrong and I don't check the OI, it might be prime, right? I mean, if that's a positive 4, it still works, but if I change that to a negative 3y, this is a prime factorization. You can't go any further. So check the OI. What did you get when you checked it? Negative 3xy, negative 1xy, negative 4xy, great. And that's guess, check, and revise, and you can do that all day. I went all the way through high school, college, master's degree, and that's all I learned. I didn't even do this little 4-term polynomial thing I'm about to show you again. But I will say, I kind of like it when it comes to having numbers like 15 or 8 or 12 or 50, things like that are out front, where I have a lot of options. You're going to see that it's actually a pretty good idea. All right, so check out number 11. So first of all, anything you can take out of here?
No.
Sadly, no. And it's such a big number, because think of my options. I could have 15 and 1, 5 and 3, and then even in those I could have 1 and 4, 2 and 2. A lot of different options I'd have to go and guess and check through. I'm just going to use my method. And what does my method tell me to do? A little magic number thing?
Add the first and the third.
Multiply the first and the third, and that would give me 60t squared. And then you say, what factors of that would combine together through addition or subtraction to give me that? So you start writing them out. Is it 1 and 60? That's not going to give me a 16. Is it 2 and 30? That's not giving me that. Is it, and again, these are factors of 60. Is it 3 and 20? No. Is it 4 and 15?
Yes. Wait.
No. Is it 5 and 12?
No.
No. Is it 6 and 10?
Yes.
Yes. And that would be, remember, I know it's got to be a positive 60, but it would have to end up being a negative 16 when you added them. So what do you think these factors are? Negative and negative. And again, they all have t's. I just didn't bother writing all of them. So now, why am I doing this again? I am going to do what? Replace this negative 16t with those two terms. So here we go. 15t squared minus 6t minus 10t positive 4. So I literally am rewriting this as a 4-term polynomial. And now what do I do once I have a 4-term polynomial? I do what? I group them. And you remember my hint on grouping them? You're going to group the first two, and you're going to group the last two, but when you group it, you're going to include that negative and put what in between?
Plus 1.
So you're going to group it and put your own plus to show that you're still adding these two things. And then once you do this, what are you going to do? From each one, you're going to see what?
Greatest common factor.
What greatest common factor I can pull out. And right here, it looks like I can pull out a 3 and a t. So I'm going to take a 3 and a t out of that. That leaves me 5t minus 2. And what can I take out of this one?
-2.
Okay, we'll take out a -2. You can take out a positive 2 also, right? But if I take out a -2, that leaves me 5t minus 2. Let's just say I'd taken out a positive 2. If I'd taken out a positive 2, these would not have matched, would they?
Nope.
Well, then go back and take another negative. So it's okay to take one out a second time. But now that I have this, what do I do with each of these?
You combine, so it's 5t minus 2.
So I pull out the 5t minus 2, and when I do that, what's left? 3t minus 2. And you can see it took me 3 steps basically to do this, maybe one more if you consider finding the numbers you split it into. And I didn't have to go through 15 different guess, check, and revise methods. And if you can find the two numbers that breaks up into, then you know what factors. And a lot of times they're prime, and you know that right away. You're like, man, I went through all the factors, nothing combines to that. I guess it's prime. What about this? Any GCF you can take out?
No.
No, so it's a big number right there. So it's a good plan to multiply them.
72.
Negative, you're looking up about the negative 72x squared. So when I think about how this splits up, one of them's got to be positive, one has to be negative, isn't it?
Yeah.
So it could either be 1 and 72, plus or minus, minus, plus.
And then 2 and 36.
2 and 36, plus, minus, minus, plus. 3 and 24. 4 and 18. 5 does not. 6 and 12. 7 does not. 8 and 9. Now you know does that make sense? Now you know your signs are different, right? So if my signs are different, for instance, negative, positive, when I combine them, I'm basically subtracting, aren't I?
Yeah.
Well, which of these, add or subtract, to give me 34?
36 minus 2.
36 and 2, and that would have to be positive 36 and negative 2. And then don't forget, there would have been an x on each of these. So I am going to replace the 34x with that. And I'm going to bring everything else down.
Minus 9.
And what have you just created? A 4-term polynomial, ready to group. So I take the first two,
2x.
I take the last two, I put a plus in the middle. And if you found these two numbers, guys, it will factor, it will not be prime. So how do I do this at this point?
2x.
2x comes out, leaving me a
4x minus 1. And then
9 comes out.
9. It's 4x minus 1.
And if the two terms match, and by the way, they can match even if they're in the wrong order. Like every now and then on a 4-term polynomial, instead of getting 4x minus 1, you'll get a negative 1 plus 4x. That's still the same thing, right? Now what comes out?
2x plus 9, 4x minus 1.
So you can pull a 4x minus 1 out and you're left with the 2x plus 9. Any order doesn't matter. Now, people look at 13 and they go, oh man, big number 12. That's gonna stink because 12 times 24 is a huge number, right? But you can take out something out of there that will make your life significantly easier. Not even just a 2, but what else? You can actually take out a 4. So that's gonna make your life a lot better if you do that. So when I pull a 4 out of this, I cannot forget about that 4. It is still a factor. 3p squared minus 7p minus 6. Now I gotta be honest with you, I might even think about guess checking and revising that, but because it says to use the magic number, I'll be obedient to myself. So what do?
3 times 6.
So 3p squared times a negative 6 would be a negative 18p squared, right? Now what factors of negative 18 would combine to give me a negative 7? Well, yeah, you jumped right to it, but it's not negative 18 and positive 1, but negative 9 and positive 2 do work out great, don't they? So I'm going to split this to negative 9p and positive 2p. I'm dropping the negative 6. I'm dropping the 3p squared, and I am not forgetting about the 4. It's the biggest thing maybe not the biggest, but I see that all the time. People forget about that 4. Just keep bringing it down. Then I'm going to group inside of this parentheses. So I'm grouping that. I'm grouping that. And I'm putting a plus in the middle. Right? And then what?
You group them together.
So I can factor out a 3p. Again, I'm inside these parentheses. That would give me p minus 3. And I can factor out a 2. That gives me p minus 3. And all of that is inside of this big parentheses on the outer. You with me on that? Because that 4 is times all of that. And then now what could I do? I can take the p minus 3's outside of this parentheses. And once they're out, what's left? 3p plus 2. Now I have a quick question. Did anybody write this instead of negative 9p and positive 2p? Did anybody write it positive 2p, negative 9p? Because let me just show you. Oh, you did? Okay, so let me show you how that changes the way it looks a little bit. So if you wrote positive 2p, negative 9p, then when you go to group right here, when you group, you're grouping that negative in there and you're putting a plus, right? It's going to look a little different. This one, now what comes out? Just a p, leaving you 3p plus 2. And then this one, what comes out? A positive or negative, but a negative is going to make it look like this, isn't it? So if I take out a negative 3, I'm left with a 3p plus 2, final parentheses. And then now I would be taking out a 3p plus 2 outside of the parentheses and leaves me with just a p minus 3 when you're done. So your work might look differently than mine, but that's okay. You with me?
Yep.
Okay. I'm going to get started on this weird thing, and I'm probably not going to get finished. So what I'm going to do is I'm going to make probably a 10-minute video, and I'm going to attach it. I don't know that it's super relevant for what you're going to do tonight. I don't know if you'll need it for tonight's homework, but it's a math team thing that shows up all the time, and well, not all the time, occasionally. So I wanted to show you, what if I asked you to factor that? Now I'm going to go ahead and tell you right now, if I ask you to factor this thing, you're going to go, I can't figure out what works. Literally, if you try to break this up, like think about it, if I try to break this up and I go x squared, y squared, y squared, those are my only options, aren't they?
Yeah.
But if I FOIL this out, what do I end up getting? 1x squared, y squared, 1x squared, y squared, 2x squared, y squared. This doesn't work. So you've probably been taught in Algebra 2, something like that, you would just say prime. But it actually factors. But you got to get really creative. So you ask yourself, what would that number need to be so that it would factor?
A 2.
A 2? Because like if I wrote it out like this,
Yeah, it'd be a 2.
it would have been a 2, right?
Yeah.
Well, what could I add to this to make that be a 2 x squared y squared if it currently is a 1 x squared y squared? What would you have to add? Another what? Another x squared y squared. Now, can I just randomly go around adding stuff? I mean, like, can I just go, oh man, I only got $20 in my wallet. I think I'll just add another 20. Now it's 40. You know what, while I'm at it, why don't I just add another 40? 80. Can you just randomly add stuff?
No.
No, if we could randomly add stuff, where would we want to go?
Just quadratics.
I want to go to the bank.
Yeah.
Go to the bank, just start adding stuff, right? We know that that's not the way transactions work. In math either. If I have an equation, we learn what? You got to add it to both sides to keep it in balance.
Mm-hmm.
But I don't have an equation here. So if I'm going to add something to this term, that makes it bigger. But I'm not allowed to just randomly go and add stuff. But what if I added it and subtracted it? Isn't that the net sum of I really didn't do anything?
Yeah.
Even though it might look different? And if I add what I need to this to make it be the 2, and then I subtract what I added to keep it in balance, it'd be like taking my wallet and taking out 20 and adding 20. It's still the same, right? I get a new polynomial. How big is it?
Pretty big.
It is now a 4-term
5-term.
polynomial, isn't it? Now, this kind of factoring, to be able to finish this process, you're going to have to know what you need from tomorrow's video. So actually, I'm not making you another video. But tomorrow when you watch the video, you're going to learn about factoring a different kind of 4-term polynomial. And when you learn that, we're going to come back and revisit this. All right.